want to go over Chapter 16 warm-up, and I'm just going to go ahead and go over the whole thing so that at home, if you're watching this video, you can stop it and watch it as much as you need to or whatever to make sure you get everything here. Alright, so it gives you all this information about the table for expected values. So, what I did for the first question where it says how many emails should the professor expect to receive each day? So that is the mean. What you expect is the mean. So I went and I put that in my calculator into Stat Edit. I put the number of emails into list 1, and then I put the probability of those events happening, or the frequency, into list 2. After I did that, then I went Stat, Calc, one variable stats of list 1, comma, list 2's frequency. And I'm getting that by going second 1, comma, which is located above the 7, second 2. I hit enter, and then what I'm looking for is the x bar is the mean of x, and the standard deviation is 1.32. So these are the expected amount of emails. So it helps you keep it straight what's going on if you label that on average 2.95 emails will occur with a standard deviation of 1.32 emails. Because next it says, all right, well, let's transform the number of emails into time. And it says it will take the professor on average 2 minutes to respond to each email. So then that means the expected number for time is going to be 2 minutes times the average amount of emails, and that's how I get 5.9 minutes as an average. Okay, so the average number of minutes is 5.9 minutes, and the standard deviation, since standard deviation is affected by multiplication, you do multiply 2 times the standard deviation of emails. So the standard deviation for minutes is 2.64 minutes. All right, E says, suppose that it takes 3 minutes to boot up this computer, and then you put on the 2 minutes per email. So that means that the function is 3 plus 2 minutes per email. So that makes a total of 8.9 minutes. But then when you are asked to do this problem for standard deviation, the addition portion of 3 plus does not affect the standard deviation. A shift of 3 minutes plus 3 does not affect the standard deviation, so it remains at 2.64 minutes. All right, now G is then an extension problem. What's the probability that the professor would have to spend more than 15 minutes for the total process of turning on the computer and answering the emails? So, again, I want you to draw the normal curve. So this means that the mean from the problem above is 8.9 minutes with a standard deviation of 2.64 minutes. X is 15 minutes. And then, so therefore, my z-score I get from 15 minus 8.9 over 2.64, so a z-score of 2.31 standard deviations up. Now, this is a curve of the average number of minutes to answer emails. You want to label your curve. Alright, so therefore when you norm CGF, you get this. So there's only about a 1.04% chance, just a little bit over 1% chance that the professor will spend more than 15 minutes answering his emails, and that includes turning on the computer. All right, next. So on the back is another problem, and this one is about the cats and the dogs, so let's take a look at that. All right, so the American Veterinarian Association, we have information here for cats and for dogs. The average for the dogs for the bill is $100 with a standard deviation of 30. Okay, and then the information for the cats is $120 and $35 for the standard deviation. So then the first question says, what's expected value for the annual medical cost for a person who has a cat and a dog? So you add. And the average of a cat and a dog, average adds as you normally expect it to. And then the standard deviation, however, does not. You do not just go 30 plus 35. The standard deviation has to do the Pythagorean theorem of statistics. So it's the square root of 30 squared plus 35 squared. So the standard deviation of the dog squared plus the standard deviation of the cat squared. And so that's a standard deviation of 46.10. All right, now we're going to find the probability that a person with a cat and a dog will have a total cost for the medical care of $140 or less. So what that is going to do is say the mean for their dog plus cat is 220. The standard deviation for a dog plus cat is 46.10. The question is having an X value of 140, and we want to go less than that. So this is the annual cost of a dog plus a cat, and we find the z-score of negative 1.74. So that makes this area, this probability, you have to norm CDF from negative 99 to negative 1.74. So there's only about a 4.1% chance that the annual cost of a dog plus a cat will be less than $140. So that person should probably budget more than $140 because there's only a 4% chance that it will average less than that. Now, the difference would be the subtraction of them. How much more would a cat be than a dog? It actually doesn't say how much more is a cat than a dog. I typically put the larger animal, the higher priced animal first. So I did cat minus the dog. And so that's 120 minus 100. You get $20 on average is the difference with the cat being higher. But here's the interesting thing. The standard deviation for cat minus dog is still the same as cat plus dog. Do you hear me? The standard deviation for cat minus dog is the same as the standard deviation of cat plus dog. I guarantee you, you have to know that. All right, so we now have got a mean of 20 and a standard deviation. So we've got a mean for cat minus dog of 20. We've got a standard deviation of cat minus dog, still 46.10. The X for cat minus dog, it's saying what's the probability that the medical expenses are higher for someone's dog than cat? Higher for the dog than cat. So the middle portion of that is when they are the same. So my X value, I got to find the location of an X value of 0 first, because that's where they're the same, all right? And then I can split it up from there. So let's find that z-score of 0 minus the mean over the standard deviation is negative 0.43. So just a little below the mean. All right. So that's right here. So I said, okay, at this point, the dog and the cat costs are the same. Now, let's think about this. This is the average difference in the annual medical cost, cat minus dog. You have to explain which way you are subtracting. If you have a positive difference, then cat minus dog is greater than 0. that means a cat costs more than a dog. All right, but over here on the left, if you have a negative difference, when you did cat minus dog and you got a negative number, that means that dog costs more than the cat. Dog costs more than the cat all over on this side of the equality spot, the z-score, or a value of 0, difference of 0. So the question is, what is the probability that the medical expenses are higher for the dog? That is over here on the left. Higher for the dog. Dog is greater than the cat. So I went to norm CDF from negative 99 up to negative 0.43, and I get 0.33. So there's about a 33% chance that someone's annual dog expense is greater than the cat expense on average. Because these are all about averages, not just like in any one particular year. On average. Okay, so I went quickly through that for those who don't necessarily need to spend a lot of time looking at it, but if that was too fast, then because this is a video, you have the ability to back up and go through it again until you follow what I'm saying. So you need to do that because every single bit of this concept is something that you are expected to be able to do in an assessment, aka quiz or test.